So in this segment, we will implement the Perceptron algorithm, and we will use it for performing some classification. As usual, let's set up the environment that we are going to use in the segment. Now, the first thing is to define some elementary operation and to write a utility function to plot the charts. So I'm using statplots. We don't need to go in details of this function here. This function simply plot nicely the data together with the linear classifiers given by the parameter theta. We are going to use always 2 dimensions, so this d1 and this 2 will always be 1 and 2, but this is more general, so you can choose to visualize whatever dimensions and to specify if you want a classifier that pass through the origin or not. And here you have also another parameters, and you will see here but I'm saving this figure, and sometimes you will see strange things like this one. This is just because I want to have different plots, and I want this script to automatically compile. 1 second, to compile and produce this one that you have on the side on the seat, so not to compile, to run and produce automatically this one. And to have these things here, I have to add to save every time I plot the figure and then retrieve it in this way. But forget about this, is only for my need to have the documentation on running on the site. So this is the function that plot the current level of classifier together with the data. The important function instead are these two. So these are the implementation of the 2 main tasks of the Perceptron algorithm, but is to determine if our classifiers, when it met one specific record, both in terms of labels and the features, make an error or not, to decide if this record is correctly or classified or not. And the second one is the consequent update. So the classification error is nothing else than the dot product between the parameter of the classifiers and the feature of the data multiplied by the label. And it is an error when it is less of equal to 0. And you can see here that instead of 0 we use this IPS, and this is a very small number. This number depends on the environment where you are, the computational environment where you are, but it seems it is needed to give numerical accuracy, because we want the 0, when is 0, to be an error, but sometimes you may have something that is very, very, very close to 0, but it's not exactly 0, because at the end we are using in floats number, they have a limited accuracy, so sometimes we end up with something that should be considered 0, but numerically is not 0, and this guarantee that we are not in that cases there, but even if we are, it's something that is a little bit lower or higher than 0, we still consider it to be an error. And the Perceptron update return the parameter, so the new parameter will be the old parameter modified with the feature of the data that created the error multiplied by the label of the data. So you can see here I'm using the dot because all these ones are scalar element-wise operations. So here is a vector, okay, it will be a column vector. Here will be another column vector that I want to multiply by this scalar here. So the result of this element-wise operation will be another vector, and I am summing two vectors, element by element, and I will return another vector of dimension d, the dimension of theta and x. So we call our function isClassificationError with our theta, with the label of the first record, and with the features of this of the first record as well. So this is with x1 and the column. If you remember in Julia, it means that we are taking the first row, all column, and it doesn't return a row, but return again a single column, a column vector. So here we call isClassificationError. Of course, it will be true, and this will lead to our first update with the element of the first record. Now this the classifier is -2 and -4. Let's gonna visualize it. It will take some time. The first time is plotted, it takes some time, and we should have classifiers that classify the first record correctly. Here it is, so our classifier that classify the first record, but we can see here graphically that the second record is not correctly classified. So let's gonna check it with isClassificationError on the first one should be false, but isClassificationError when we use the second record, we have a true that is an error. This leads us to make a further update with the second, taking the second record to run the update, and we can visualize, and now we can see that the two records are correctly classifiers, and we can see that calling isClassificationError with the two records, and in both cases false. Let's take another example here with a little bit more tricky, with where the first record is still 2, 4, and the second record is 1, -2, still with -1 and -1 as labels. So we resetted here the theta, and we ask the first one, of course, is true, so this leads to make an update, and we visualize. So here it was our first record, and it correctly now classify this first record, but still we have another one. So the first one is not an error, but the second one is a classification error. So we run an update with respect with the second record, and look here. Even if you run the update here, the update is not enough to classify correctly this second record. At this point, so when we do with one is false, but when we do with the second record, we still have an error, and this leads to a further update, and only now we can see graphically and here that the classifier correctly classify both the records. So here is a further example, 2, 4, -2 and 2 as second, and in this case the labels are -1 and 1. So our first classifier classify correctly on the first update the first record, but the second one, this is a plus, so it doesn't classify correctly. So we run a second update, and now the classifier correctly classify this one as negative and this one as positive. At this point, we can put these bricks together and make the whole Perceptron origin algorithm, where in terms of functions that accept x, y, and here we have the parameters, the number of epochs, that is it, the number of times we run over all the data. We also have another parameter here to set the verbosity of the function. So our Perceptron origin functions will start with making zeros on the classifier's parameters, then it runs over through the epochs. It runs for each epoch over through the records, and then it does these things that we said earlier. That is it, if it finds an error, and only in this case it will update the parameter of the classifiers, and it return at the end, when it finish with this algorithm, it return the final data of the classifier. So we can check it here, so we can call it with our x and y currently, and we should have when we run the classifiers, we should end up with the same classifier that we have here, and here is the case, so it's the same figure because of course it was the same data. Let's now to test our Perceptron origin function with something more interesting than just a couple of points. And we load first BetaML and delimited files, because the data that we are going to use now is provided in the package BetaML. So we load some data, and we give the name Perceptron data, and if we are going to open it, Perceptron data, where is it? Here. We can see that we have some data in 3 columns, where the first column is the label, either -1 or 1, and the other 2 are numerical columns that will represent our features. So we saw that the data is not shuffled. So the first things, we need to shuffle it. So we take here the index, and we take the data and we index the rows with the shuffled index. So we effectively shuffle the matrix across the various rows, and we take as x the second and the third column, and as y the first column. At this point, we can run our algorithm through all the 200 data, and it's very fast. As you can see, it printed here the various updates when it has been updated every time. And we should have here, we can print it, and we should have, it takes some times, I don't know why, but because the first time we are printing here, and should return the classifiers. And you can see here, it didn't do bad, it's the best he could have done. Remember that we are forcing it to pass through the origin, and it does quite a good job.